Let's talk about one of the most important partnerships in our world, iron and carbon. When you put them together, you get steel. But what is carbon's role, really? Is it the hero that gives steel its legendary strength? Or is it the villain that creates a fatal flaw? Well, as we're about to find out, the answer is yes.
I mean, just take a second and look around you. Steel is absolutely everywhere. It's in the skyscrapers that shape our cities, the railroads that connect us, the cars we get around in, and even the tiny, precise surgical tools that save lives. There's no exaggeration here. It's the material that literally built the modern world.
And that kind of brings up a big question, doesn't it? How can the same basic material be both incredibly rigid and surprisingly springy? What's the secret sauce that gives it this incredible range? Well, it's not some rare, exotic element from a faraway land. It's carbon. Good old carbon. That simple, super abundant element is the master controller. It's the secret architect that decides exactly what kind of personality a piece of steel is going to have. And the crazy part? The amount you need is minuscule, but the effect it has is absolutely monumental. Okay, so let's start with the good stuff. Let's look at carbon in its heroic role. What are the amazing superpowers it gives to what is otherwise just soft, simple iron? So first, let's get a quick baseline. When we say steel, what we're really talking about is an alloy, a mix of iron with just a tiny pinch of carbon thrown in. And I mean tiny. We're talking between 0.1% and 2%. It's kind of wild to think that such a small change can have such a massive impact. And make no mistake, the experts are all on the same page here. Carbon is, without a doubt, the single most important ingredient you can add to steel. It's the main dial that metallurgists get to turn to control how the final material is going to behave. Now, this is where it gets really interesting. This graph shows you carbon's power so clearly. See on the bottom? That's the percentage of carbon, going from pretty much 0 up to 1%. And on the side, you've got hardness. Just watch that curve. It doesn't just climb, it skyrockets. A tiny increase in carbon, say from 0.1 to 0.6%, makes the steel more than 3 times harder. That's carbon's signature move right there, giving steel incredible strength. So adding more carbon makes steel harder, which means it resists getting bent or dented. It boosts its tensile strength, so it's harder to pull apart, and it improves wear resistance, so it lasts longer. But how? Okay, think of pure iron atoms like a perfect stack of playing cards. They slide past each other really easily. Now imagine you sprinkle a few tiny hard grains of sand, that's the carbon, in between the cards. All of a sudden, it's a lot harder for those cards to slide. That resistance, that's what we feel as hardness and strength. But this incredible power comes with a dark side. And that brings us to the flip side of the coin. Let's talk about the price steel has to pay for all that strength, and why sometimes carbon can act a lot more like a villain. Yeah, just like in any good story, there's always a trade-off. You don't get all that strength and hardness for free. The very thing that makes steel so strong also introduces some pretty critical weaknesses. For starters, more carbon makes steel less ductile. That means instead of bending, it's more likely to just snap. It also reduces its toughness, and you can think of toughness as its ability to take a punch without shattering. That's a huge deal. On top of that, it makes the steel harder to weld and can cause something called embrittlement, which can make it dangerously fragile, almost like a piece of glass. This chart shows that toughness problem perfectly. Each of these lines is a steel with a different amount of carbon. See that solid line way over on the left? That's low-carbon steel. It can absorb a ton of impact energy, even when it's freezing cold. But look what happens when you add more carbon. The lines shift way over to the right. That steel with 0.8% carbon, it becomes brittle at temperatures well above freezing. It totally loses its ability to absorb a shock. Now just imagine a bridge made of that steel on a cold winter day. Yeah, not good. So what do? We've got a hero and a villain all wrapped up in the same element. Well, the solution isn't to pick a side. The solution is to find the perfect deliberative balance for every single job. This graph right here, this tells the whole story. As you add more carbon, that's the axis along the bottom, look at the 2 lines climbing up. That's tensile strength and hardness going up and up and up. That's our hero getting stronger. But look at the 2 lines on the bottom. At the exact same time, ductility and toughness are taking a nosedive. It's a perfect seesaw. You literally cannot get more of one without sacrificing the other.
And this is where engineering becomes a real art form.
The ASM Metals Handbook, which is basically the Bible for this stuff, calls it a strategic balance. It's not about finding the one best steel. It's about intentionally engineering the right steel for a very specific purpose.
And here's how that strategic balance plays out in the real world. If you're making a car body, what do you want? You want it to be tough and ductile so it crumples in a crash instead of shattering. So you use low-carbon steel. For something like a railroad rail, you need a mix of strength and toughness. That calls for medium carbon steel. But for a knife or a spring, hardness and wear resistance are everything. So you go with high carbon steel and you just accept that it's going to be more brittle. See? Every single choice is a deliberate trade-off.
So here's the most important thing to remember. Carbon isn't inherently good or bad. It's just a dial. And the real genius is knowing exactly where to set that dial for what you want to accomplish. Let's do a final side-by-side. Low-carbon steel, it's softer, more ductile, tougher, and way easier to weld. High-carbon steel, it's the total opposite. Harder, more brittle, stronger, and trickier to weld. Neither one of these is better. They're just different tools for different jobs. And really, that's the main takeaway here. The real magic of modern steel isn't just the discovery that, hey, carbon makes iron stronger. It's the centuries of science and engineering that have gone into precisely controlling that relationship, dialing in the exact percentage of carbon to create the perfect material for a specific job. So let's go back to our original question, hero or villain? By now, you know the answer. It's neither. Carbon is simply a powerful and incredibly versatile tool. The knowledge of how to use that tool is what makes it a hero or a villain in any given story. Which leaves us with one final thought. What new balances will we find? And what amazing new things will we build as we continue to master this incredible little element?